so let's, sorry, this is a little late. Why did I say I'd make so many tests? All right. We were talking about calculating with significant figures, and part of that is that the measurements that you use, um, the calculations you do with measurements can't be more accurate than any one of the measurements put in there. And I compare this to a chain can't be stronger than the weakest link. And so if you are multiplying and dividing, the answer has to have the same number of significant figures as the weakest of the numbers that were used. So for example, here we have 12.51 meters and we're multiplying it by 0.00524. Now this was measured to 4 significant digits and this was measured to 3 significant digits. So when you get a calculator answer, you're going to get something in this case with 1, 2, 3, 4, 5, 6 significant digits. And we can't have an answer that has more significant digits than either of the things that made it up. So we need to round this number and we need to round it to whatever was the least number. And the least number there was 3. So we need to round this to 3 significant digits. So since leading zeros are not significant with a decimal, we're looking at 6, 5, and in this case, it would end with 6. So that's how many significant figures that has. In the case of division, the same thing. We can have something like 0.006750 liters that has 1, 2, 3, 4, and 32 liters, which has 2. When you divide those numbers, you get 0.0002109,375. Which has 1, 2, 3, 4, 5, 6, 7, I think, if I counted that right. So you can't have an answer with 7 significant figures when your input was 4 and 2. So you want to round this to 2 places so that it's the same as the weakest of the numbers that went in, and that's 0.00021 liters. All right. And then we go on to density. So density has the formula of mass divided by volume. Now, some people wonder how to do this, and we're going to go through a few ways. Mass is expressed in either grams or kilograms. Those are the units of mass. Volume is expressed as milliliters, liters, or centimeters cubed. And hopefully you remember now that milliliters and centimeters cubed are the same thing. And a few ways to remember that density equals mass over volume. You can remember this triangle, which is sort of the DMV. Density equals mass over volume. Mass equals density times volume. And volume would equal mass divided by density. That's the nice thing about that triangle. The problem is you got to remember what order they go in. Another thing someone told me is that density equals a heart with a line through it. And if you draw a line through a heart, you get something that looks like an M for mass, and you get something that looks like a V for volume. So that's another nice way to remember that. All right. If you have 35 grams of lead that is displaced, a volume of 2.5 mils, what is the density of lead? So as you think about that for a second, I'm going to try to find my pen here in my studio. All right. So density is equal to mass over volume. The mass is in grams. So we're looking here. We're looking not there. Don't look there. We're looking here at the 35 grams as the mass. So 35.0 grams is the mass, and the volume is the 2.50 mils. And that will give us the density. And 35 divided by 2.50, everybody knows, is monkeys. Everybody knows that 35 divided by 2.50 is 35 divided by 2.50. 35 divided by 2.5 is equal to 14. So now we know that this is equal to 14. All right, from current side. So that equals 14. Of course you did. 14 grams per mil. So that's the density of lead. Gold has a density of 19.3 grams per centimeters cubed. A cube of gold measures 2 centimeters at each side. What's the volume of the cube? So if you have a 2 and a 2 and a 2, we just learned that that's going to be 2 times 2 times 2, which is 8. So it's 8 centimeters cubed is the answer to that one. I don't know why that didn't have another question. And then if I asked you what's the mass? So then we would take the 19.3 grams per centimeter cubed and multiply it by the 8 centimeter cubed. That would cancel your centimeter cubes and leave you with grams. Or you can do, like we set up here, that we're looking for the mass. So we're going to take the density and multiply it by the volume. And the volume's 8. So 8 times 3 is 4. Carry the 2. 8 times 9 is 72, which is 74. Carry 7. 8 plus 7 is 15. And then we move it over there. So it should be 154.4 grams, which needs to be, since this was 2 significant figures and that's 3, we want it down to 2. So that would be 150 grams, significant figure wise. All right. I'm going to stop there because it's late. Discard everything. All right. Have a great night, kids.